So we want to continue from where we stopped. Remember, in the previous tutorial, I think we were cut off abruptly. So we're trying to explain this formula right here, which is a formula of conservation or conservation constraint. So this conservation constraint applies to the flow network. It also applies to the edges. So it says that for each node V other than the S or T, we have summation of all the flows into V is equal to summation of all the flow on all the edges out of S. So let's illustrate it. Let me take my pen again. So let's draw a little network and then we'll use it to illustrate. I'm going to use red. So let's say we have a network like this, a simple flow network, and we have, remember the graphs, the edges has to be directed. This is T, and all these points here, this is S, these points here, and these points here. So assuming this is A, B, C, D. So what we are saying is, we are saying for each node V, which is not S or T, so for all internal nodes, so for all these internal nodes, so this is what is referred to as V in this case. So we say summation of all the flows going into this box is equal to all the flows coming out of X. So we calculate flow on this edge. Let's say flow F on SA plus F on S what? SC, which is this edge. So this is the flow coming out of S, right? So SA and SC. So we say that summation of this is the same as summation of the flows going into this, which is ultimately the same as summation of all the flows going into T. So that is conservation. So let's now define the maximum flow problem, because that is ultimately the problem we want to solve in flow network, and that is why we talk about the Ford-Fulkerson algorithm. One thing I want you to do is for you to understand this problem, alright? So the goal is to arrange the traffic so as to make as efficient use as possible of the available capacity. Therefore, the maximum flow problem states that for a given network, find the flow with maximum possible value. So let me take my pen so I can illustrate it and then it becomes clearer. So let's assume we have a network like this. Let's just say a network like this. So let's say we have this to be T and this is S, right? So we have the capacity of this to be 7, capacity of this to be 6, and capacity of this, let's say we have the flow going here, capacity of this to be, if we have 7 here, let's say we have capacity of this to be okay, let's say 10. So we have 7, we have coming into this, going into this place 7, so we have this to be 3, right? Because 3 plus 7 gives us 10. Alright, so let's say we have this to be what? We have this to be 3. Alright, so let's leave it at this for now. So the total flow coming out of S is what? Is 7 plus 6, which is 13. The total capacity coming out from S, and the total going into T is what? Is also 13. So now, assuming we want to choose the flow, let's say, is it possible that we can have a flow of 13? Let's say we have 3 we have 3, we have 3, and there, now we have 6, value of 6, which does not follow. So we are trying to say that we need to try to find the flow that is as close as the capacity as possible, and that is the maximum flow. Somehow, practically, we might not be able to have a flow that is equal to the capacity. That is practically. Theoretically, yes, we could have a flow that is equal to the capacity, meaning that we can have a flow that uses all the capacity, but most times in practical purposes, that is not always possible because of the internal design of the flow network. So what I want you to understand is what the maximum flow problem is all about. Alright, so how do we solve this problem? Do we just keep putting numbers arbitrarily everywhere? How do we know that it has come up to the maximum? So that is the problem we want to solve, and that we solve using Ford-Fulkerson algorithm. But before we'll be able to design this algorithm, we need to understand the concept of cuts. The concept of cuts is really very important, and that is actually what we are going to discuss next. I'd like to thank you for viewing. We continue in the next tutorial. Remember to click on subscribe if you have not subscribed.